Okay, let's talk for a minute about what standard work actually looks like. So, what I'm about to show you is kind of like a graduate level concept. Essentially, in this case, what you're looking at is a U-shaped cell. And what that means is that the flow of the work is going to go in a semicircular motion like this. And, it's obvious reasons it's called a U-shaped cell. But this puts a lot of higher level standard work principles in place. So, if you think about each of these items here as a self-contained work unit, that's a very high level concept. You can move your work around and adjust it as needed. So if you want to change the order, if you want to split it into different layout, you want to change it from, let's talk about number of people. So this is set up maybe for having two individuals working in here. And if you want to add three people, you can change the layout a little bit more. Now, as you start diving into what standard work actually is, each person needs a little bit of work, like a piece of material to work on. So that is called standard WIP, standard work in process. And in addition to each person needing a piece of material to work on, all of your automated machines need something to work on. So if you don't want to have a person standing there watching their work being drilled or soldered or whatever it is on a machine, inspected, tested, whatever, if you don't want a person to have to stand there and watch, you need another piece of work. And you'll also notice that as you start flowing the people around in their work, each person has a pattern of work they do. I would like to point out that as you do this work, each person needs a very precisely defined sequence of operations. So it has to be the same way every time and not just these little workstations. Within the station, the steps they take, their process steps in each workstation needs to be identical. So when I say identical, I mean repetitive. That no matter who's doing it or the time that the person's doing it, it will always look the same. So it should be assigned to a single individual too, so that that person should not be doing shared work. There shouldn't be a step that whoever's done first does it. Each person has to have their own specifically assigned sequence of operations. Now, sometimes you will come into a situation where two people need to do a task together. I always recommend making those people do that first. So you might have to kind of play around with how your standard work flows. But at the start of a cycle, you want both people working together because it eliminates the problem of timing it up. So one person might get ahead or behind the other one, and you don't want anybody waiting. If you start at the beginning of a cycle, once everything flows, and if you're talking about assembly line, if everything shifts, you'll be able to make sure that it's always sequenced up and you don't have any waiting involved. So again, be very precise in how you structure your work. And in some cases, like I described, the sequence is very important. In other cases, it might not seem important, but if you time it out, you'll realize that putting the right tire on the back of your go-kart is faster than the left tire or the front or back, but basically the way the work is flowing, one will be timed out better than the other one. In the rare instances where that isn't the case, you still want to choose which way they do it because eventually something will shift within your workstation. You might move some tools around or you might reorganize something or change the location of a piece of equipment and it'll change things. And if some people are doing it one way, some people are doing it a different way, it affects things. So standard work becomes this very important basis. So you want to make sure that you are very clear in the sequence. Now, another thing you might notice here is the work is flowing counterclockwise. And the reason for that is most people are right-handed. So if you kind of look at the operation of a person as they're walking, if you're walking past something, your right hand is always to the work, even when you're moving. So you can be doing something even as you're proceeding through your operation. Basically you're able to move while you're working a little bit, or as you're carrying a piece of work from station one to station two, you don't have to be carrying it across your body because most people are going to be wanting to put it into the fixture, whatever they're doing with their right hand. So counterclockwise flow. Now, after that, you'll also notice that as I talk about work in process and timing, it'd be very easy to conceptualize how if this operator over here finishes up their work and they come over here to grab another piece, if it's not timed up well and this person's running a little late and they don't have the work exactly done, you run into some timing issues. So this is called transition whip. And basically what it means is you put the piece of work here, you walk over here, and there should be another piece there you pick up and work on station 8 if you're operator 1. So there's always be a piece of work between the two operators. So they would, if you can imagine how this flows, at this point, he's just finished working number 7, puts it over here, walks down, picks up the piece of work and starts working on it. This operator finishes up her work, moves over to number 2, and when she finishes it now, this person's moved around maybe at station 5, she can put her work down and then they can move over to station 8 and there'll be a piece of working over here. So the transition whip makes it very easy to keep the flow going without having to be precise in the timing because, stuff happens. And then, it also has material flow. And the material will flow in standard work. You have to define how the material is going to move through your operation. And I will point out here, and I don't think I talked about it very much earlier, but you have automatic machines also need to work. And I didn't mention this, but this type of machine, you can make things even easier by using auto ejectors. And it's called a Hanadashi device in the Japanese term. And if you set up a bunch in a sequence, they call it chaku chaku, and it's load. So if this machine here has a piece of work that's going on and it ejects it, when the operator comes across and wants to go to this location, they'll be carrying the work from station 3. They can place it right into station 4 and then grab the piece that was ejected and move over to station 5 and start working on it. So if you set things up in a really sophisticated way, you can make the work flow extremely fluidly through your operation. And that's all there is in this one. So, yeah, that's the basic layout of what standard work is. And again, this is a kind of a graduate level orientation to it. The key here is that it's got to be very standardized, obviously standard work, but the level of which you have to make sure you're precisely following the work in a specific order every single time is very important. We'll talk about some of the components of standard work in just a minute. Have a good day.